Welcome back. Today I'm going to be going over the elevation cliffs and connections for an RM script, and I'm combining these sections because they're relatively short. So before I started with that stuff, I wanted to mention one thing first. I was wondering why this map looked so compressed compared to the sample I had, and then I realized I had copied wrong. These borders are supposed to be 5% rather than 10%. So now that means we're trying to cram all this into 81% of the map's area instead of 64%. And that's a big difference. So the first topic to talk about here is elevation. This section comes after land and before cliffs. And as you may guess, this section puts hills on the map where we specify. You need to have an elevation generation section in the map to create any hills on the map. You may think that's rather obvious, but you may forget to do this for one command in particular. You see, before creating the patches of elevation that are usually created in this section, you can also set the base elevation of a land to be what you want. But that is done in the attributes of the specific land rather than in the elevation generation section itself. So say, for example, I wanted the elevation of this particular land to be higher than everything else. I can type base elevation, leave a space, and specify the height of the elevation. Now, elevations range from height 0 to height 7. That's a larger range than the scenario editor can produce. It can only go from 0 to 6. So if I specify a base elevation here, the height of this land will be what is specified. So click generate, and we can see that this land has risen above everything else to the elevation we specified. And you need to have the elevation generation section in this map for it to work, because if you don't have that, you get these black patches of terrain where the hills are supposed to be, and if you tried to test this map, the game would crash. So always remember to have this in here. Alright, we don't need this anymore. Aside from that, the only other command in elevation is this create elevation, leave a space, and specify the elevation you want. In our case, it's going to be 2. And this has attributes that include your base terrain, number of tiles, number of clumps, and your scaling. Alright. The base terrain of our map is self-explanatory. In this case, the player's lands are the place where we want to create our hills. And since the terrains haven't been generated at this point in the script, the base terrain is going to be water. And now we need to define how much of the map is going to be elevated. And we have this number of tiles. Elevations don't have a land percent attribute, but you can approximate the overall percent. Unscaled values refer to a map size of 100 by 100, which is a total of 10,000 tiles. So approximating land percent is as easy as dividing the number of tiles by 100. So 1,250 tiles is approximately 12.5% of the map. Number of clumps is fairly self-explanatory. It just specifies the number of hills that are going to be created. And then scaling here is the same as terrains. You can scale by size, which makes your hills get bigger as map size increases, or you can scale by groups, which increases the number of hills as map size increases. So we have that. Generate, and that's what that looks like. We have our elevation created. Okay, so those are the most common attributes for elevation. And there's this other one called spacing. Elevation commands avoid player start areas to begin with. So what this attribute does is it allows your hills to elevate gradually. See, if I add a spacing here, hit generate, doesn't show very well here. See, if I add a spacing, you can see that there's a space between each step of the elevation here. but that's not something we're going to need for our particular map. And that's about all there is to know about elevations. So now we're going to talk about cliffs, which are even more straightforward. So the cliff generation section of a map looks like this. And the thing to know about cliffs is that if we leave this alone, we add no commands here, just have this by itself. We generate the map, and we see that we have some cliffs on our map already. So the cliff generation section of our map is probably the one we have the least control over, but we can define how cliffs are created by utilizing other sections of our script. For example, cliffs have no terrain specification in the section. They automatically avoid player starting locations, and they're able to be placed on most terrains in the game. It's important to know what those terrains are, but it's more important to know what terrains cliffs cannot be created on, and those are water, medium water, deep water, shallows, and ice. And just as I say cliffs can't be created on water, you look at this and you're probably confused because cliffs are clearly on the water in this map. But you have to take into account the order in which the sections of our map are generated. Cliffs come after land but before terrain. So before the terrain generation section of our map takes place, these terrains are sort of switched. This is water. You see no cliffs here. And the outside is land. So cliffs can be created here. Alright, so that's how that works. There's a few commands associated with cliffs, such as these. Alright, the first four are fairly self-explanatory. In our case, we're going to have, say, 20, 22, so we're going to create between 20 and 22 cliffs on our map with each generation. Specify the minimum length of a cliff as 5, the max as 8. The ambiguous stuff here is probably cliff curliness. That's supposed to define the shape of your cliffs. Higher values are supposed to make your cliffs curlier, but personally I don't really see a difference in changing this value, so I just usually leave it out and the map is perfectly fine. So the only thing left is this, which is a min distance cliff. That just defines how far each cliff in your map is going to stay apart from another one. And in our case, it's going to be 10. Let me see. That changed slightly. Alright, so there's one other thing to know about cliffs. So let's for a second change the base terrain of our map from dirt 2 to dirt. And let's find a cliff here. Let's take a look at the difference between cliffs created with our map and cliffs created in the scenario editor. So we delete both, and we see that the one generated by the script leaves this grassy terrain behind. And this is important to know. Since terrains come after cliffs, if you specify in a terrain command to avoid other terrain types, they're also going to avoid cliffs because this terrain is underneath that. This terrain does not grass, but is constant number 16 if you find that useful for other purposes. It's also important to note that cliffs do not have a scaling factor. For terrains and elevations, they can be scaled with commands like these, but cliffs don't have that. For the case of this map, I have my min and max cliffs set for this particular map size, but those amounts are for a 4v4 size, which would be too big for a 1v1 size map. So the most common way to scale your cliffs manually is by using an if structure. An if structure looks like this. You start with if and state the case for the particular map size. The game knows these to be the predefined names for the particular map sizes. You're going to state your case for the particular map size. Use else if to state your other cases. and you're going to close the structure with an end if. Okay, so now to talk about connections. Let's put those after terrains because that's where they occur. Okay, so the connection generation section joins lands together by replacing the terrains in between them. There's different ways of connecting lands, and those are defined by any one of the following commands. So you can connect players' lands, you can connect teams' lands, you can connect the same land zones, or you can connect all the lands on the map. I'm not going to go through each one of these individually. For the case of our map, we want the players' lands to be connected while still avoiding the center, so we're going to go with the first option. And this has attributes. So the first thing to specify in connections is what terrains will be replaced and what terrains are going to be the replacements. In the case of this map, we want the water between players to be replaced with shallows. So type replace terrain, leave a space, and type the terrain that's going to be replaced, water, leave another space, and type the replacement terrain, which is shallow. Alright, so now the thing to know about connections. If we take a look at this, imagine each endpoint here is a player's base, and a line between them is a connection with the adjacent player. Connections don't do this. Connections are like this. They go from one player's base to all of the other players' bases, and similarly, all the other players' bases are going to do the same, making connections look like this. And trust me, it's not that pretty in game. So in order to avoid this, we implement what's called terrain cost. Terrain cost is just a value that defines how easily connections will pass through a given terrain. Values range from 0 to 15. Low values let connections pass through a terrain easily. High values make connections avoid passing through a terrain. And in-between values may allow connections to pass through, but take the shortest path possible across that terrain. It's not an exact science. There's a lot of variation involved. So for this particular map, the terrain costs are these. The terrain cost of the water is 3, so connections will fairly easily pass through that terrain. The desert has a cost of 15, so the connections will avoid passing through that at all costs. And the medium water has a cost of 10, so connections will still avoid passing through, but not as much as the desert. Alright, and the final thing to define with connections is the terrain size. That is done by terrain size of the terrain that's going to be replaced. In our case, it's going to be water. Leave a space and type the width of the terrain, 5, and then type the variance. So we have defined our width to be 5 and our variance to be 0. So it's going to be 5 and exactly 5, as opposed to a variance of 1 would make a width of between 4 and 6, but that's not what we need. So if we test this, see connections on our map have been created, and if you notice, there are some connections that look thicker than 5, and all that means is there's multiple connections being passed through adjacent to each other. And that's about all there is to know about those topics. I do hope you've learned something, and I'll see you later.